Next presentation is about Razor, and directly after this presentation we have the next presentation without break. Okay. Oh, sorry, that's David Lutterkort. Oh Mann, das Essen ist mir nicht bekommen. Lutterkort, sorry.
Hi, I'm David Lutterkort. Yeah, a little bit about me. I'm German, but I've been living in the States for much longer than I care to admit. So it's great to come back for an occasion like Puppet Camp here, and I'm actually really amazed to see how big the event is and how many people are here. It's really gratifying to see how much interest there is in Puppet and all things config management. I've been with Puppet Labs for about 6 months now. Before that, I was at Red Hat for a really long time. I was one of the earliest contributors to Puppet. It was actually, I think, 8 years ago today, well, the day before Thanksgiving, 8 years ago, that I was looking at various config management systems because the only thing I had seen at that point was CF Engine, and that seemed clearly not great. And back then, there were things around like BCFG2, something called LCFG, something from CERN that I never quite understood. It came with like a 500-page manual. And then Puppet. And I mean, what struck me about Puppet at the time was that Luke seemed to have a really good handle on the problem and was very good at expressing, the problem he was trying to solve and how he was approaching it and all that, which appealed a lot to me. Along the way, I got frustrated with some aspects of like managing files with Puppet, and so I wrote Augeus. If you're still editing config files with sed and grep, stop doing that right now and go have a look at Augeus. It's a much better way to do that, much safer. But I'm here to talk about provisioning. How many of you manage physical hardware? Okay, that's a good swath. And I assume most of you provision them with PXE booting. How many of you use a homegrown tool to do that? Okay, Cobbler? Okay, anything else? Probably XCAT. Does anybody use XCAT here? I hadn't heard about that until a few months ago. So provisioning is clearly a problem. There's quite a few tools out there. I don't think that many people are happy with the tools they have. And kind of to prove that point, I made up a user survey. And with make up, I mean invented the data to prove that something needs to be done. This is actually how you do software engineering, in case, total aside, but this is how results in software engineering come about usually. Razor was started about a year and a half ago by two people at then EMC, then now at VMware, Nick Weaver and Tom McSweeney. Was launched May of last year at EMC World, and then Nick gave a talk about it at PuppetConf last year, which was really well received. Lots of people there, lots of excitement around the tool. I think very justified, and as part of kind of moving on, because Nick and Tom aren't really in the business of maintaining software, especially not for production. They kind of handed the code to Puppet Labs, and when I came on in May, the first thing I had to do, or was asked to do, was look at Razor and figure out how we can put that into the product, into Puppet Enterprise, and fix a few warts along the way. And that's what I've been up to together with a guy called Daniel Pittman. The two of us are kind of the Razor, the main force behind Razor right now. So what makes Razor unique is, I don't know how many of you have heard the whole pet versus cattle thing, usually in the context of cloud. But that's what Razor tries to do. One of the things that makes existing PXE provisioning solutions really annoying is that they force you to treat your servers as pets, right? Your pet has a name, and you care for it, and when it gets sick, you take it to the vet, and you're very, very concerned and very attached to it. And a lot of PXE provisioning solutions force you to think the same way, right? If somebody comes and says, I need a database and a web server, you go in the data center and go, maybe that one over there and this one. Then you go back to your office, look at the spreadsheet where you have all your machines or your asset tracking system. enter the MAC address of these systems into your provisioning tool, and at some point you have something installed on there. And what Razor does is it lets you treat these machines much more like cattle, like this. Not as cute as pets, but in a lot of ways easier to deal with. And just as there are cattle that you raise some cattle for meat and some for milk and some for breeding, probably. Razor lets you look at various aspects of your systems and kind of pick what you want to use for certain things, depending on attributes of these systems. How much memory does it have? How many CPUs are in there? Those kind of things, so that you can kind of forget about it's that individual server and more. I need a database, and databases go on machines that look like this in my data center. That you can set up policies like that. And all that is, Razor's driven by policy, which is, again, based on rules. One of the things that makes Razor, I think, unique in the provisioning space is that when a machine boots for the very first time, we boot it into a little discovery image, a little Linux image that in Razor speaks called the microkernel. We boot it into that, and it runs factor and sends the facts back to the server. And then in your policy, in your rules, you can say, you can match based on facts of a system. Which gives you a nice tie into how Puppet does things. And based on these rules and policy, you select what should be installed on there. Should it be CentOS 6.4 or Debian or ESX or what have you? And then at the end of the installation, you can hand the machine off to a broker, which usually is usually a config management system, usually Puppet. So there's a really easy way to bootstrap your infrastructure from powering it on to all the way to it's enrolled with Puppet. The whole thing gets automated with Razor. Okay, so what does the thing look like? Even though it's Pixie provisioning, what we deal with is a web server, and I'll get into how we get out of the whole TFTP misery in a minute. So the main Razor code is just a garden variety web service. Using HTTP, we use Postgres as the database. How many of you have looked at the old incarnation of Razor, the one that was initially launched? The initial thing had a lot of web scale stuff in there, like MongoDB and Node.js, and part of what I wanted to change to productize it was get rid of a lot of these things, because what we learned is that there's not that many people who feel comfortable operating MongoDB, for example. It was really hard to set up. At a talk like this, when I asked who's using it, a couple people asked, does trying to install count as using it? That's how hard the old code base was. With the new code base, it's written in Ruby. It's a fairly standard Ruby web application. We use Postgres as the database, for one, because I think lots more people know how to run and operate Postgres, how to take backups, disaster recovery, all those things are pretty well known. Two, I'm really impressed by Postgres, how they kind of took the challenge that this whole NoSQL thing threw down for relational databases. Over the last few years, a lot of features have shown up in Postgres that go towards like schema-less things, so that in a lot of cases you don't need to kind of leave the comfort of a relational database to get a lot of flexibility. Anyway, so Postgres as the database. Anybody who's ever deployed Ruby applications knows what Veil of Tears that is, with Passenger and Thin and all Unicorn and whatnot. What we're doing is, instead of using one of those, we use TalkBox, which is kind of a plugin for JBoss that turns JBoss into a Ruby app server. It's as a developer, it's a really nice platform to develop on. It means you're running a JVM. It also means that we're using JRuby. The usual MRI Ruby seems to segfault a day before you release pretty reliably. So JRuby, TalkBox, and then as the web framework we use something called Sinatra. If you haven't come across it, it's you can think Ruby on Rails after a very, very serious diet. It's it's a really nice framework to write simple web services. Okay, so to set the thing up, you need Postgres. All the other things on the previous slide you kind of get with a release. You also need to do some preparations for your machines to talk to the web server, because PXE booting, of course, requires DHCP and then TFTP, and then you're off to the races. So what you need to do, what Razor doesn't do, is we don't try at all to manage a DHCP server. We don't try to manage a TFTP server. But at the end of the day, you have to put two files on the TFTP server. One is the iPXE firmware, which is a little binary that you get from the iPXE project, open source firmware. And the other one is a little script for iPXE that the server will generate for you. And once you have these two files in place, you don't have to touch DHCP, TFTP ever again. Everything important happens on the Razor server. The thing that makes this possible is that iPXE lets you go from TFTP, where your machine downloads the iPXE firmware, and then that script basically says talk via HTTP to the Razor server. And the nice thing about iPXE is that it lets you do that it lets you talk HTTP from a pretty basic pre-boot environment. What you'll wind up with is you'll have a bunch of nodes, the systems that get managed by Razor. You have clients, which might be your laptop, which you use to control Razor, to set up policy and things like that. And that's kind of what a deployment looks like. The node is the central concept in Razor. When it's bound to a policy, meaning we've installed something on it, we note that in the database we store some metadata about it, like the facts, and a couple other things in the database, and you can query all that through the API. So those are the machines we manage. And when a machine comes up for the first time, it does the usual PXE boot dance. It gets the iPXE firmware and the little script, and then goes to the server. Hey, I'm here. What should I be doing? And as the first thing, the server sends down the microkernel, which it used to be based on TinyCore Linux, which is a little bit of a off-the-beaten-track distribution, which has the disadvantage that there's a lot of hardware out there that the TinyCore kernel doesn't deal with. Like if you have Dell and HP systems and NICs and HBAs in there that that kernel doesn't like. Part of the rewrite we're doing is that we've changed the microkernel from using TinyCore Linux to Fedora, because that kernel is much more widely used. And ultimately, if we run into troubles, it's a very easy way to go to RHEL. Because Puppet, we can't be in the business of hardware support for low-level operating system stuff. There's companies that do that. Red Hat's one of them. And most of our customers have RHEL contracts anyway. So by putting the microkernel on RHEL, you know who you have to call up if things go wrong with your hardware and some driver doesn't work or weird things don't happen. So the microkernel is a fairly stock. Right now it runs about 130 megs, fairly stock image, and we stick a little Ruby script in there that basically doesn't do anything else, but it runs factor, sends the facts back to the Razor server. The Razor server thinks about them and then comes back with a command and tells the microkernel what to do. And the commands are really right now hang tight, there's nothing to do, or reboot because the server wants to provision something on there, wants to install an operating system on it. In the future, we'll add more commands. I'll get to that in a bit. The thing about the microkernel is once you've got the machine booted into it, it will continually check in with the server. By default, every 15 seconds, it will run factor, send the facts, ask, is there anything for me to do? If not, wait a little bit, do the same thing again. Which gives you really fast reaction times. If you change something on the server in the policy, and all of a sudden that machine should have a database on it or something like that, the gap between the machine noticing that it should do something and you setting it up is on the order of seconds. Okay, so there's two APIs that the server uses, and depending on what you're trying to do, they're of different importance. On the client side, there's a RESTful interface that you use to look at your nodes, to set up policy, to Yeah, we'll get into policy in a little bit. Basically, to control the whole thing, kind of the management API for Razor. And on the back end, there's a little API that the node can use when it's installing something to get additional information, additional files. Before you can install something with Razor, you have to set up a few things through this REST API. One is a repository, which is where the bits live that you want to install on there. You can either take like a Ubuntu install ISO and import that into the server, or point the server at an existing repository that you already have. That's the repository. The broker is the thing that at the very end kicks in to hand, basically to tell something else. This thing is ready now, and this is what it looks like. Do something with it. Usually you set up a Puppet broker so that at the very end of installing on that, the node goes to the Puppet master and says, hey, I'm a new node, and here's some information about me. Do something with me. But there's one guy who's written actually really interesting broker that just broadcasts stuff on a message bus via some AMQP plugin. So there's a lot of flexibility there what you can do with these brokers. Tags are actually the rules that policy is based on. So a tag says if the machine has more than 2 processors and more than 16 gigs of RAM, call it a big machine, or call it a such and such machine. And then later on, the policy says machines that are tagged with these tags should get this operating system installed on them. And installers finally are the things that actually do the installation, and they're little more than whatever you use to do automated installation of your systems. So if you're doing a RHEL or CentOS install, the installer is a kickstart file and maybe some post-install shell script that you want to run once the node reboots. But it's if you have the installation of your operating system automated, the installer is like five lines of YAML metadata that you have to add. It's very, very lightweight. Okay, so the microkernel has been sitting there, sending facts, and been told there's nothing for you to do yet. We've set up all these things on the server, and now a policy applies. We've determined that something, say RHEL, needs to be installed on that node. The server says to the node reboot. And when the node comes back and says, hey, what should I be running? The server now tells it, here's an initRD in kernel, which happened to be the initRD in kernel for the RHEL installer, for example. And then from there, it downloads a kickstart file, and there's, as I said, there's a little API that the node can use to get things like there's, you can. In the installer, you can have ERB templates for your kickstart file, for example, or some other files that you might need during the installation. So you can fetch that. You can store some information about the node on the server, like the IP address of that node, if you want to have that in the database on the server, which will then later show up in the client-side API when you look at that node. You can log messages, right? You can say, oh, I successfully downloaded this script, I successfully installed some packages, whatever, or log some error messages that get attached to the node on the server. And then finally, you can tell the server that you're done with a certain stage of the boot process, that you've done the basic installation, the node's now ready to reboot and run a post-install script. All the installers are really just linear sequences of steps that say, first you boot into this image, then you boot into that, and then after that, after a certain point, you'll always boot locally because you're done installing. And to get from one step to the next, the node has to say, I'm done with a certain step. Razor comes with a number of installers. They're kind of the most annoying thing to write. Not so much because of what you need to do for Razor, but just because some operating systems are harder to automate than others for installation. So we have installers for the various RHEL flavors, RHEL CentOS. You can use it for Fedora too. Similarly, we have an installer for various Debian flavors, Ubuntu. Some guy actually just polished it up to work right with Ubuntu 12.04 LTS. And then a very recent addition are the two other installers I showed there. One is an installer for ESXi. That was actually the initial use case to write Razor was provisioning ESXi on hosts in a data center, given where Nick and Tom work. Not a surprise. Surprise is how hard it is to get ESX rolled out in an automated way. I don't know how many of you have tried that. It's gut-wrenching. There's lots of weird things you have to do. And then finally, something we just added is an installer for Windows. I think right now it only works with Windows 8. But that means, and we'll expand that over time, but that means you can use Razor to provision all these things, hopefully all the OSs you use in your data center with one solution. Okay, so I just want to go through a few examples of, because right now I'm sure it's kind of nebulous, the various things I said you need to set up on your server. Just go through a few examples of what they look like. And the first one is a tag. So a tag is really just a name and then a rule that looks like this. And if you squint hard enough, it looks a little bit like an S expression, but like a Lisp type expression. It's really just JSON that looks a lot like that. So what this thing says is, if either of these two conditions is true, this tag will apply. The first condition is if the MAC address is one of the ones given here, then this thing will apply. Or if the node has exactly 2 CPUs, then this tag will apply too. So there's a lot of, and with these, of course, there's not equals and greater than and things like that. And with access to the facts about a node and this sort of logic language, you can actually express a lot of complexity about your nodes and classify them in fairly fine-grained ways. So if one of these tags matches, the node is tagged with that, and we'll see later how that is reflected in the policy. The other thing you need is an installer, and as I said, besides the things you need anyway to automate installation of your operating system via Pixie, this is all you need on top of that. These, I don't know, 5 lines of YAML. Most of it is just information. The really important thing is this thing here, which says the first time this node boots into this installer, use the boot install template, which is another file that comes with the installer. And then after that, once the node has told you it's successfully done this stage here, from then on just use the boot local template to boot. And I kind of jumbled up my slides, I think. Let me do this first. So this is what, for example, the boot install template looks like. It's an ERB template, and it really talks about, this is just one line from it, right? It talks about we want a certain kernel and a certain kickstart. And these little helpers here generate URLs. This is actually a little subtle. These helpers just generate URLs, and then this text with KS equals some URL gets sent down to the node. The installer running on the node will then request that make a request against that URL to the server, which then sends it down the actual kickstart file. Similarly for the kernel, we say repo URL here because we want to pull something out of the kind of the repository, the binary content that's associated with the policy we're installing. So you can think of this as the file vmlinus on your install ISO or install CD. And below is an excerpt from kind of the post-install script for the rel installer, where we say set the host name to whatever is stored as the host name attribute of the node we're installing currently. And down here, we install a bunch of packages, and if that works out, we log something on the server, and if it doesn't work out, we log something else. So I glossed over the broker this is an example of what a Puppet broker would look like. All you need to say there is that you're using the Puppet broker type, which is again, a couple scripts somewhere that ultimately cause the Puppet agent to be installed on the system, and the Puppet agent then talking to the Puppet master. And so the important things that the the most important thing that the Puppet broker needs is where the name of where your Puppet master lives. And the other two aren't that important, but you can say that if I use this Puppet broker with a node, it should automatically go into the production environment. Okay, and tying this all together is the policy. The policy is kind of where all these different things we've set up come together, and where you say, this is a policy to install CentOS. You say use the CentOS 6.4 repository. This is where all your packages and the various bits live. Use the CentOS installer, which is the Kickstart files and templates and whatnot. I want to use the Puppet broker I just set up. Down there is a little bit of metadata that gets filled in as soon as a policy is applied to a node, as soon as that policy matches the node. We set the node's host name according to this little template there. We set a root password on the node too, mostly as a convenience. You can turn policies on and off by flipping this enabled flag. You might want to, for some time, not use some policy, so you can just turn it off, or to have some other policy take precedence. And you can also say how many nodes you want to have at the most using this policy. So you can say, I only want 5 database servers, and you set the max count here to 5. And then the rule number. So policies are organized in a table, and Razor just goes through that table one by one, and the first policy that matches a node gets applied to it. So earlier policies take precedence over later policies. And the rule number is a way for you to organize this table, to sort these policies into the table. And finally, you have to say what tags this policy uses. As soon as a node comes by that has all the tags that I mentioned here in the policy, that policy applies to the node. And that's kind of the long and short of Razor. And I think you should. I don't know how many of you have seen this movie. You should maybe think of your nodes not so much as cattle, but as little helpers that help you do even more evil. So I wanted to, as one example of kind of the cool things you can do with something like Razor, I wanted to talk about cloud a little bit, mostly about you have a bunch of physical systems and you want to install some cloud on it. And one of the things you might want to put on there is VMware, vCloud, what have you. And to do that, that's actually pretty easy in that you just use the ESXi installer in your policy, which puts down the ESXi nodes. And then you use a special broker that actually talks to your Puppet master. On your Puppet master, you have to have a module from the Forge. There's a vCenter module that takes care of all the weird munging and actually talking to vCenter at the end of the day. So Razor, once it's installed a node with ESX, it goes to the Puppet master and says, hey, here's a new node, and I installed ESX on it, and here are some details about it. And then with this module, the Puppet master will actually go and tell vCenter about the nodes that are out there and enroll them with vCenter. And then all of a sudden, basically you turn on a machine and at some point it shows up in your vCenter. The whole thing is fully automated. Another one is, I don't know how many of you have played with OpenStack or used OpenStack, tried to get OpenStack going. I mean, OpenStack has their own provisioning solution, which is kind of fledgling. But this is a very cool way to set up OpenStack. Again, you need some modules from the Forge. We have these OpenStack modules that you can use to manage all kinds of aspects, or pretty much anything in OpenStack. And initially I wanted to do a demo, but I didn't think I would have time for that. So what you need for these OpenStack modules to set up a cloud with them is you need 2 networks. The red network is kind of your provisioning network, and then a green network, which later on the virtual machines that run on these hosts will use to communicate. Yeah, and I see the slides kind of still show the VMware logo instead of, of course you're not installing ESX on those nodes, you're probably installing some sort of KVM-based hypervisor on those nodes. And what that looks like in terms of Razor is, there's two kinds of nodes in the simplest setup. One is a controller node that runs kind of pretty much all the OpenStack services besides the actual Nova compute, and there's a compute node or many compute nodes that run just one of those OpenStack services. Like the other OpenStack services are things like Glance, which is the image store, maybe some networking service, Keystone, which handles authentication. There's a database, MySQL, on the controller node and all these things. But all you have to do to kind of get this setup going, or similar setups, is you write one policy for the controller node. And here I've pegged the max count to 1. So I only ever will get one controller node that looks like this. For the installer, you just use a stock Fedora or whatnot installer. You don't even need to worry about anything OpenStack specific. And so you use this policy, and then a second policy for compute nodes, and they pretty much looks the same except for the highlighted things that I had changed. Like I changed the rule number. There's a different tag. For example, when I ran this on my laptop, I gave the controller node 2 disks, and the compute nodes only 1, and so I distinguished between the two of them by whether they had only 1 disk or 2. And in your Puppet manifest, this is pretty much the entire Puppet manifest you need to get this going. You say if the host name of the node has controller in it, you use the OpenStack controller class and a bunch of networking information. If the host name has compute in it, we use the OpenStack compute class, again, bunch of network information basically to make all those nodes find each other, and that's pretty much it. And then you turn on the machines, and everything after that just works, or hopefully works. Yeah. So basically, Razor and Puppet together are a really powerful tool to fully automate. I like to talk about Razor as serving not the last mile problem, but the first mile problem, the problem of actually getting Puppet bootstrapped on the machine. And then Puppet can do the rest of the things. So what does the future look like for Razor? Besides PXE provisioning, I look at Razor as a kind of a machine lifecycle tool that you should be able to use during the whole lifecycle of a physical hardware. Or, I mean, everything I talked about also works with virtual machines if you PXE boot your virtual machines. But things like BIOS updates, for example, should be possible with Razor. So there's a lot more commands that both the microkernel should understand and things that clients should be able to put in there, like a command to boot into a BIOS update image, right? Just boot into this thing once and then go back to booting locally to whatever was installed on the machine, together with a tag language that lets you hopefully select which machines actually need the BIOS update, right? So you could, as the client, you could say all machines that look like this boot into this firmware or BIOS update image. And it might take you a while because some of these machines that should get the update might be running something. So it might not happen until the next scheduled reboot of that machine. If they're running the microkernel, it'll happen in a few seconds. Other things that that you could do there is reinstall the OS, for example. Or rediscover the node. You might have a newer microkernel that collects more facts than what you did initially when you discover that image, that node. So similar to like a BIOS update, you might want to boot into a microkernel once and then go back to whatever the system was doing. Another thing that's really important if you have other external systems managing or managing some aspects of your your machines is a way to generate events, like to tell a CMDB that a machine has shown up, right? That it has booted. So that's kind of the other big thing I want to do in Razor. One thing we don't have right now, but that Daniel's working on right now, is controlling the power of your nodes. So using IPMI to turn machines on and off. Right now, we just rely on you to do that somehow out of band. But once we have that, we can offer a public API that actually lets you, boot up and down machines. So you can boot up a machine, discover it, inventory it, and then power it down. And when Razor decides that something should go on the machine, Razor can power the thing back up for you and install something on it. Okay, that was it in a nutshell. Wow, OpenOffice, I don't know if anybody can read the links on there. I don't know why OpenOffice decides to make them light gray on white background. Yeah, there's IRC channels at the bottom, my email address if you want to sign me up for cat pictures or stuff like that. Okay, so with that, thanks for listening, and are there any questions? Can you use custom facts during the initial node discovery phase? Right now, that would require that you rebuild the microkernel, or at least crack it open and put some external facts in there. But we would like to make that easier in the future, but it's definitely possible. Yeah.
I don't understand. So we buy, I think, about 200 servers a year.
Mm-hmm.
But there are 3 or 4 types of machines.
Mm-hmm.
But they have completely different tasks.
Mm-hmm.
We have completely different kickstart
Mm-hmm.
templates, and we have completely different configurations. And how can I achieve? You talked about these rules, and the rules are about numbers of processors,
Mm-hmm.
numbers, size of RAM. All the machines look the same. How can I select a machine to be a database server and it looks like the same like in file server?
Mm-hmm. Yeah, so the question is, what if I buy 200 machines a year that all are basically the same hardware, but are supposed to do different things? How can I distinguish those? If you can't tell from inside the machine, if they're really the same machine, then what do you even need to distinguish between them? Right. If they're in different network. Yeah, no. What I'm saying is that if you have 200 machines and they're all the exact same thing, then you don't need to, and you have 3 or 4 different types of installs that you want to perform. You don't necessarily have to subdivide those 200 machines into 3 or 4 groups. You just have to set on your policy, for example, you bump that you set that max count to however many you want right now. And if you want 1 more of this type, you increase the max count by 1, and Razor will pick one of those identical machines and install on it. And then you use different installers there. And you might have 1 installer for your database and 1 installer for your web servers. They might lay down the exact same OS, but this might do different partitioning or something like that. Whether you want to do that with different installers or 1 installer that is more templated, where the partitioning, for example, is just templated out, is something that depends on the specific use case. Yes.
I've actually got 2 questions. First one being, if I should manage my servers like cattle,
Mm-hmm.
I'd like to name them like pets.
Mm-hmm.
How do I do that?
Okay, so if you want to manage your server like cattle, but you want to name them like pets, how do you do that? Right now, where did I have this thing here, right? The host name line here is pretty restricted in that all we give you is an ID, which is some number. There's a lot of people on the mailing list who would want to have more pet-like names for their machines. It depends a little bit on what you want to do. Sometimes people just want to have them numbered using different schemes or use some facts in that, and those are things we need to add to the stuff you can put into the dollar parentheses things. It depends on where the information for your naming comes from. If it's based on facts, it would actually be a really simple change to do that. If it's something that needs to be generated, for example, they should have numbers from. They should be called web server 50 through 60 or something like that. That would require a little more headache, I think, on the implementation side, just to make sure you reuse gaps that, as you decommission something, Razor notices that 55 is free, is available now. Those things, but yeah, I mean, it really depends on the very specific kind of naming scheme you have in mind.
The second question is basically if you have to remotely install a server that is not in your Pixie network, like you can do in Kotlin, and boot up a system with a custom image.
Mm-hmm.
Will there be some sort of support for this?
Yeah, I mean, there's a couple ways to do that right now.
David, sorry.
Oh, sorry, yeah. So what if you're not using Pixie? What if you don't have DHCP turned on in your data center or things of that nature? So you can either take the microkernel directly and stick that. Let me just think if that would work. I mean, what definitely works is if you burn, the iPixie firmware to some media, like a CD or something like that, and boot from that, because Razor doesn't care if the iPixie firmware was downloaded via TFTP or some other means, or just sits there in a CD or something like that. It might screw a little bit with your local booting. I'm not sure, but essentially, that's the idea. Put some media in there that. I assume that's what you're doing today if you're not using Pixie?
Yeah, it's basically the image that
yeah. Okay, more? Yes.
You just said that you are able to command the system to reboot when it's idle to do some kind of BIOS update or whatever. How is that achieved? Is there some sort of Razor daemon that's running while operating?
Okay, yeah, so I said that you can tell the node to reboot and then run some BIOS update image. That's not quite true. I mean, that's not what I meant when I said that. The one thing is, if the node is running the microkernel, we can tell it to reboot immediately because it's sitting there and asking the server all the time what to do. We don't put a Razor daemon or anything in the operating system that gets installed. And for that to reboot, you have to wait until the machine gets rebooted for some other reason, right? That somebody manually reboots it, or once we have IPMI control, we could actually let you do that through the Razor interface. That you can say, these machines, reboot them now, and then boot into some BIOS update image, for example. Yes.
Plans for some a little bit more sophisticated deployments. For example, let's say we have our HP ProLiant with a bunch of disks, and we want to configure RAID 6, which requires a license key to be entered on the RAID controller. Is there some sort of that available right now, or plan for the future?
So is there?
License management, just pick a license from a pool of licenses.
Yeah. So the question is, if you have to do more complicated things like on an HP ProLiant RAID setup that requires you to enter a license key, other ways to do it. Right now we don't have support for a pool of licenses. If you have some external service that does that for you, you could just fetch it from there, because your node, all it has to be able to do is talk HTTP to some other service. And we can, Razor can certainly help you construct that URL in a way that makes sense to your license management thing. The question of these sort of pools comes up a lot, mostly in the context of networking and assigning IP addresses, where you want to say, where you kind of want to use Razor as a poor man's DHCP server that generates an IP address on installation and then uses that to set up static networking in the OS. It's also something we want to do, we haven't done yet. Okay, yeah. More questions? Yeah.
Is this, I'm going to be a bit lazy. I'm going to ask you, is this an open source tool or is it an enterprise tool?
Go to the GitHub repo. No, it's open source under the ASL like Puppet. It will show up in Puppet Enterprise 2 very likely in the next release 3.2 that we're going to make. But yeah, everything I talked about right now is in the open source version there. Okay, and with that, thanks a lot. And if you have more questions, I'll be here all day.
Thank you.